Hello everyone. Today we are going to start with the video lectures for the first chapter of ICE subject SEM 7 EXTC branch. The chapter name is Introduction to Internet. And before we start with the video lecture, I hope मेरे बच्चों ने वो जो video मैंने post किया था, how does the internet work, they might have viewed it because it is a little bit important and there are many concepts in that video which is not being introduced in many of the books, and it's quite fascinating to view with animation and graphics. So yes, let's start with our first chapter, that is nothing but the introduction to internet. Now, many of my students have a doubt that what do we mean by a network? What is a lowercase internet? What is a higher case internet? These things have been sorted out very simply in the PPT. Now, the first thing that first a network. What is a network? A network is nothing but a group of connected communicating devices such as computers and printers. Uh, uh, an internet, uh, an internet you can what do you say note that the lowercase I is for two or more networks that can communicate with each other. Now, the most notable internet is called the internet with a capital I, now which is composed of hundreds or thousands of interconnected networks. But of course, if we are talking about many computers being connected, these are nothing but the private individuals as well as the various organizations such as government agencies, schools, research facilities, corporations, and libraries in more than 100 countries across the world use the internet. Now, uh, it is very fascinating to know that the users are more than a billion in number, but still we say that it is millions of people are active users as of the data. But this extraordinary communication system came into being only in 1969. So yes, before that there was no internet. Before that there was no networking concept. All this came being into 1969. So what are the actual phases that we are looking into? What were the first stages in the development of internet? Let's begin. Now, in the mid 1960s, mainframe computers in what do you say in the research organization were standalone devices. Computers, I would say, from different manufacturers were unable to communicate with one another. It was then that the Advanced Research Project Agency, the ARPA, in the Department of Defense, but of course in America, was interested in finding a way to connect the computers together so that the researchers they funded could share their findings, thereby reducing cost and eliminating duplication of effort. So now, what happened is in 1967, at an association for computing machinery ACM meeting, the ARPA, or I would say the Advanced Research Projects Agency, presented its idea for ARPA Net, a small network of connected computers. They were the first one to give that idea. Now, what was the idea actually? The idea was that each host computer, not necessarily from the same manufacturer, would be attached to the specialized computer, would be attached to a specialized computer called as interface message processor, or in another words known as IMP. Now, the IMP in turn would be connected to each other. So each IMP had to be able to communicate with other IMPs as well as with its own attached host. मतलब मेरे पास अगर सिंपल सा डिवाइस है एंड इफ आई एम लिविंग इन 1969, so the ARPA community, they presented up an idea wherein your computer can be connected to a local IMP, wherein that IMP will be connected to different IMPs, and those different IMPs will be connected to the respective computers of that specific domain or that specific region. Now, by 1969, ARPANET was a reality. Now, what happened is four nodes at the now one at the University of California at LA, known as UCLA. The second at the University of California at Santa Barbara, uh, UCSB. Then Stanford Research, the third one being installed at Stanford Research Institute (SRI), and last and not the least, we have a University of Utah, which were connected via IMPs to form a network. Now, software called uh, the Network Control Protocol, or the NCP, provided communication between the hosts. This was the main, what do you say, initialization of, what do you say, the internet. Now, the birth of the internet, still we were just having connections across different computers. Now, what was internet and how did it came into, what do you say, configuration? Now, in 1972, Vint Surf and Bob Kahn, these two important people, they both of whom were a part of the core ARPANET group, collaborated on what they called the interneting project. Now, what they wanted is they wanted to link different networks together so that a host on one network could communicate with a host on a second and different network. Now, but then there were many problems to overcome. First of all, there were diverse packet sizes, then I would say diverse interfaces and diverse transmission rate or data rate, as well as differing reliability requirements. So now what happened is Surf and Khan devised the idea of a device called a gateway to serve as the I would say intermediary hardware to transfer data from one network to the another. उन्होंने क्या किया उन्होंने they designed a gateway wherein it can serve as an intermediate what do you say बीच का catalyst के जैसा wherein it can what do you say uh, normalize every detail that is being required by the system. Now, the first and the foremost thing what happened is there came the birth of TCP/IP, or in another word, the Transmission Control Protocol or the Internet Working Protocol. It is being said in that way. Transmission TCP/IP. Now, Surf and Khan, they both published a paper. That is why a paper publishing is important for your work. Now, they both published a paper in 1973 which outlined the protocols to achieve end-to-end delivery of data. They were the first person to achieve that feature. Now, this is a new version of NCP. Remember, NCP was a simple software which was being used to provide communication between four nodes that we had discussed earlier. Now, this paper on transmission control protocol, or in another words TCP, included concepts such as encapsulation, the datagram, and the functions of a gateway. What are those things? We'll cover each and every topic slowly and smoothly. As of now, just understand that these are some important terms which are being required for the smooth functioning of an internet. Now, a radical idea was what do you say was the transfer of responsibility for error correction from the IMP to the host machine. That was one idea. Now, this ARPA internet now became the focus of communication effort. Then, around this time, responsibility for the ARPA net was handed over to the Defense Communication Agency, that is nothing but the DCA. Now, in October 1970, I guess 77, an internet consisting of three different networks: ARPANET, packet radio, and packet satellite was successfully demonstrated. Now, communication between the networks was now possible. So it was very much important. What do you say after that? Now, shortly after that, the authorities made a decision to split TCP into two protocols. One would be called as TCP/IP, or the Transmission Control Protocol, and the second one would be called as the Internet Control Protocol. Now, Internet Control Protocol, or Internet Protocol, not Internet Control, Internet Protocol (IP) would handle datagram routing, while TCP would be responsible for higher level, what do you say, functions such as segmentation, reassembly, and error detection. Now, the new combination, I would say, became to be known as TCP/IP. Now, it would be known as TCP/IP. Now, in 1981, under a contract named as DARPA, the UC Berkeley modified the Unix operating system to include TCP/IP. Now, what was it? This inclusion of network software along with a popular operating system did much for the popularity of the networking. Now, what happened is the open implementation of Berkeley Unix gave every manufacturer a working code based on which they could build their products. So now the Berkeley guys, what did they do is that they made up open source software so that it can be easily, so that the TCP/IP can be easily implemented on that what do you say open sourced hardware. Now, in 1983, authorities abolished the original ARPANET protocols, and the TCP/IP became the official what do you say protocol for ARPANET. Now, those who wanted to use the internet to access computer on different network had to be running TCP/IP. Now, there are what do you say different what do you say stages of TCP/IP. How did it come into existence, so on and so forth. So we'll go very smoothly about each and every one. The first one was Milnet. Now, Milnet is what in 1983 ARPANET, the first one, ARPANET splitted into two networks: Milnet for military network and ARPANET for non-military network. Now, so Milnet is being divided into two, Milnet for military and ARPANET for non-military. Now, CSNet. Now, another milestone in internet history, I would say, was the creation of CSNet in 1981. Now, CSNet was a network sponsored by the National Science Foundation. The network was conceived by universities that were ineligible to join ARPANET due to an absence of defense ties to ARPA. Now, what are the basic importance of CSNet? CSNet was a less expensive network. Now, over here, as you can see, CSNet was a less expensive network. Then there was no redundant what do you say links, and the transmission rate was slower. But of course, transmission rate slower is one of the disadvantages of CSNet. Now, it featured connections to ARPANET and Telenet, the first commercial packet data service. Telenet will cover up later. Now, by the middle of what do you say 1980s, most US universities with computer science department were a part of CSNet. Now, other institutions and companies were also forming their own networks and using TCP/IP to interconnect. The term internet, originally associated with government-funded connected networks, now referred to the connected networks using TCP/IP protocols. Then there came NSF net. Now, with the success of CSNet in the 1980s, the NSF in 1986 sponsored NSF-Net, a backbone that connected 5 supercomputer centers located throughout the United States. Now, what was the importance? That is, community networks were allowed access to this backbone. A T1 line with a 1.544 Mbps data rate. Trust me, it was a very big achievable feat in those days. 1.55 Mbps in that days was something very important. Now, with a 1.544 Mbps data rate, thus providing connectivity throughout the US. Now, in 1990, ARPANET was officially retired and replaced by the NSF net. Now, in 1995, NSFNet reverted back to its original concept of a research network. It was being taken back. Now, ANSNet. Now, what happened is in 1991, the US government decided that the NSFNet was not capable of supporting the rapidly increasing internet traffic. So, what did the people do? Three companies, namely the IBM, Merit, and MCI, filled the void by forming a non-profit organization called Advanced Network and Services ANS to build a new what do you say high-speed internet backbone called as ANS Net. Now, the internet today, as you can see into the diagram, it is made up of what do you say the internet is not a simple hierarchical structure. It is made up of many wide and local area networks, LAN, joined by connecting devices and what do you say switching stations. It is difficult to give an accurate representation of the internet because it is continuously changing. New networks are being added, existing networks need more addresses, and networks of defunct companies need to be removed. Today, most end users who want internet connection use the services of internet service provider, that is nothing but the ISPs. Now, there are international service provider, national service provider, regional service provider, and local service providers. The internet today is run by private companies, not the government. Please do pay attention over here, bacha, that it is being run by private companies and not by the government. The diagram over here shows the conceptual view of the internet. Now, as you can see, I would just keep the diagram over there. I would expect everyone to just draw this diagram so that it becomes easier for you to recollect. Just pause the video over here and just take a book and a pen and just draw this rough diagram in your notebook or a rough book so that it becomes easier for you to understand when I'm moving to the further slides. Now, I would, what do you say, go on with the each and every detail. Now, what do we mean by backbone ISP? Backbone ISP are nothing but are created and maintained by specialized companies. Which you can see over here, backbone ISP. Now, there are many backbone ISPs operating in North America. Some of the well-known are Sprintlink, PSINet, Unit Technology, Aegis, and Internet MCI. To provide connectivity between the end users, these backbone networks are connected by complex switching stations, normally which is run by a third party. called network access points. Now, some regional ISP networks are also connected to each other by private switching station called peering point. Now, backbone ISPs normally operate at a high data rate. For example, in those days it used to run at 10 Gbps for an example. Now, we have regional ISP. Now, what do we mean by regional ISPs over here? Regional ISPs are small ISPs that are connected to one or more backbone ISP. Now, they are the second level of hierarchy with a lesser data rate. Then moving on to the local one. Now, what do we mean by local ISP? The local ISP provides direct service to the end users. Now, the local ISPs can be connected to regional ISPs or directly to the backbone ISP. That is one of the beautiful feature of local ISP. Now, most end users are connected to the local ISPs. Note that in this sense, a local ISP can be a company that just provides internet services, a corporation with a network to supply services to its own employees, or a non-profit organization such as a college or a university or India's number one Universal College of Engineering that runs its own network. Now, each of these can be connected to a regional or backbone service provider. These are the, what do you say, various things that are we discussing. Now, the World Wide Web. Now, the 1990s saw the explosion of the internet application due to the emergence of the World Wide Web. The web was invented at CERN by Tim Berners-Lee, one of the important person to invent the what do you say, World Wide Web, the one person to give you www dot. Now, this invention was added has added the commercial application to the internet. If you look into the timeline over there, the first one in 1969, the four node, the one which we had discussed up till now, it was nothing but the four node ARPANET was established. Secondly, in 1970, ARPA host implement the NCP. Then in 73, there was a development of TCP/IP suite. Then in 77, an internet was being tested using TCP/IP. In 78, the Unix distributed to academic and research sites. In 1981, the CSNet was established. In 1983, TCP/IP becomes the official protocol for ARPANET. But of course, in 83, Milnet was born. In 86, NSFNet was being established. In 1990, ARPANET was decommissioned and was being replaced by NSFNet. And NSFNet goes back to being a research network in 1995. And lastly, in 1995, again, companies known as the ISP started. So they came into picture. Now, the growth of the internet. Once it was being established, the internet today has grown tremendously. In just a few decades, the number of networks has increased from tens to hundreds of thousands. Now, concurrently, the number of computers connected to the network has grown from 100 to hundreds of millions. This is somewhat very fascinating, bacha. Now, the internet is still growing. Factors that have an impact on this growth include the following three important points: new protocols, new technology, and increasing use of multimedia. Now, new protocols, first example, the new protocols are need to be added, and deprecated ones, means the ones which are being outdated, uh, needs to be removed. For example, a protocol superior in many respects to IPv4 has been approved as a standard, but it is not yet being fully implemented. My students might be knowing about IPv6. They might have heard the term IP version 6. So yes, they might be familiar with IPv6, but till now it is not being implemented on a large scale. It is still into talks. Secondly, new technology. Now, new technologies are under development that will increase the capacity of networks and provide more bandwidth to the internet users. Increasing use of multimedia. Now, uh, it is predicted that the internet, once just a vehicle to share data, will be used more and more for multimedia. For example, TikTok. Protocols and standards, somewhat important that we need to discuss. Now, in this section, we will define two widely terms: protocols and standards. First, we will define protocol, which is synonymous with the term rule, and then we will discuss standards, which are agreed upon rules. Now, what do we mean by protocols, beta? Protocols are nothing but, what do you say, communication. First, let us understand what do we mean by protocol. Now, protocol, communication between two people or two devices needs to follow some protocol. A protocol is a set of rules that govern communication. Now let's take some example. For example, in a face-to-face communication between two persons, there is a set of implicit rules in each culture that define how two persons should start the communication, how to continue the communication, and how to end the communication. Similarly, in a telephone conversation, for example, there are set of rules that we need to follow. There is a rule how to make a connection, for example, dialing the phone number, how to respond the call by picking up the receiver, and how to greet, how to let the communication flow smoothly by listening when the other party is talking, and finally how to end the communication by hanging up. Now, in computer networks, the communication occurs between entities in different systems. An entity is anything capable of sending or receiving information. However, what do you say, two entities cannot simply send bit streams to each other and expect it to be understood. For communication to occur, the entities must agree on a protocol. That is why it is much more important that in internet connection a protocol is defined at first hand. Now, a protocol defines what is communicated, how it is communicated, and when it is communicated. The key elements of a protocol are syntax, semantics, and timing. Three important parts, bacha. Now, what do we mean by syntax? Now, syntax refers to the structure or format of the data, meaning the order in which they are presented. For example, in a simple protocol, a simple protocol might expect the first 8 bits of data to be the address of the sender, the second 8 bits to be the address of the receiver, and the rest of the stream to be the message itself. Now, the data order is also applied to the order of bits when they are stored or transmitted. But of course, जब वो भेजे जाएंगे या जब वो रिवर्स खींचे जाएंगे, at that time the syntax is being kept intact. The data order is also applied to the order of the bits when they are stored or transmitted. Now, different computers may store data in different bit orders. When these computers communicate, this difference needs to be resolved, which is why it is important. Now, semantics, second point. The semantics refers to the meaning of each section of bit. How is a particular pattern to be interpreted? उसको describe कैसे करोगे आप? And what action is to be taken based on that interpretation? For example, does an address pair identify the route to be taken or the final destination of the message? That is an example of semantics. Now, uh, timing. Timing refers to two characteristics: when data should be sent and how fast it can be sent. Now, for example, if a sender produces data at 100 megabytes per second or 100 mbps, but the receiver can only process the data at only 1 mbps, देने वाला देने के लिए 1000 हाथ से देता है, पर इंसान के पास सिर्फ 2 हाथ है बेटा, तो वो ले नहीं पाता। इनपुट पे लोड हो जाता, व्हाट से हमारे इनपुट रेजिस्टेंस पे लोड गिर जाता है बेटा. The transmission will overload the receiver and the data will be largely lost. Standards. Coming to the second point, standards are essential in creating and maintaining an open and competitive market for equipment manufacturers, and also in guaranteeing national and international operability of data and telecommunication technology and processes. They provide guidelines to manufacturers, vendors, government agencies, and other service providers to ensure the kind of interconnectivity necessary in today's marketplace and in international communication. Now, data communication standard falls into two standard categories: de facto, meaning by fact or by convention, and de jure, meaning by law or by regulation. Now, let us understand what do we mean by those. De facto means the standard that have not been approved by an organized body but have been adopted as standards through widespread use are de facto standards. जैसे कि मेरे बच्चे बंक मारते हैं, it is not being approved by any body but it is being universally what do you say accepted कि भाई सब लोग करते हैं, adopt करते हैं. Hence, de facto standards are often established originally by manufacturers that seek to define the functionality of a new product or technology. Examples of de facto standards are MS Office and various DVD standards. De jure. Now, de jure standards are those that have been legislated by an officially recognized body. So this was up till what do you say the basic part of the internet. In the next lecture, we'll be starting up with something a little bit advanced and something more interesting. Up till then, stay safe and thank you.